we have discussed about the SI units of the 7 basic quantities that are prescribed by the SI system. Okay. So, we have discussed that from these 7 base units, we can derive the units of other derived quantities. For example, we can derive the unit of area and volume from the unit of length. We can derive the unit of density from the units of mass and volume. Okay. So, let us see how we can derive the other quantities. So, let us say area. We know that when we talk about area of different surfaces, let us say if we are talking about the area of a square, it is generally the length of the side of a square raised to the power of 2. Okay. If we are talking about rectangle, the area is length into breadth. Okay. If we are talking about a circle, the area is pi r square. So, everywhere where we measure area, we see that there is a term where some quantity of length is raised to the power of 2. Side is also measured as length. Length and breadth, both of them have units of length, and radius is also nothing but length. So, area is basically length square, right? So, the SI unit of length is meter. So, we can say that the SI unit of area will be meter square. Okay. So, although the SI unit of length is meter, for example, if we are measuring the length of a piece of cloth, we measure them in meter. But when we are measuring the length of a pencil, it is such a small quantity that we cannot measure in terms of meter. We measure it as centimeter. For further smaller items, we measure in terms of millimeter. Generally, for scientific purposes, there are other units like nanometer or angstrom with which we measure atomic distance or wavelength. Now again, if we are talking about the distance between two places or distance between two cities, we will not measure them in meters. They are so large that we measure them in kilometers. So, one quantity can have several units. Okay. One quantity can have several units. Okay. The SI system was also formed to standardize these measurements. Okay. When we are providing a scientific report, we generally try to convert all the quantities there in terms of SI unit. Okay. Now, the SI unit of area is meter square according to this system. We can also measure them as centimeter square, millimeter square, etc. Now, if we are talking about volume, then we generally see that volume has length raised to the power of 3. That is, if we are talking about a cube, the volume of a cube is generally side raised to the power of 3. For a cuboid, we have length into breadth into height. When we are talking about the volume of a sphere, we have 4 by 3 pi r cube. Okay. So, everywhere when we measure volume, some quantity of length is raised to the power of 3. So, we have length raised to the power of 3. So, since the unit of length is meter, we can call the unit of volume as meter cube, okay, or meter to the power 3. Now, let us say speed. Speed is distance divided by time, right? Now, distance is length and time. Both of these are basic quantities, but speed is not a basic quantity. So, how will we derive the unit of speed? So, the unit of distance is meter and the SI unit of time is second. So, the SI unit of speed is meter per second. Okay. Generally, when we are talking about vehicles, okay, that is the speed of a car, we don't talk about meter per second, we talk about kilometer per hour. Okay. This is the speed generally we use for vehicles. But when we are talking about something scientific, that is the speed of light. Speed of light is 3 into 10 to the power 8 meter per second. Then we denote in terms of meter per second. Okay. Now, if we know speed, then we can also find about acceleration. Acceleration is velocity divided by time. Here we are not talking about vector quantities, so let's consider velocity as speed. So, meter per second divided by second. So, the unit of acceleration is meter per second square or meter into second to the power minus 2. Similarly, when we talk about force, what is force? Force is mass into acceleration. So, unit of mass is kg and unit of acceleration is meter per second square. So, the unit of force is kg meter per second square. This is also known as Newton, which is written as capital N. Okay. Now, if we talk about energy, energy is force into displacement. So, the unit of force is Newton, which is kg meter per second square, and displacement is nothing but length. So, the unit of displacement is meter. So, the unit of energy will be or actually the SI unit of energy will be kg meter square per second square, which is known as joule and written by capital J. Okay. So, this is how we can derive different other units for other quantities based on these 7 base units. Now, we were talking about that one quantity can have different units. Like for length, we have meter, centimeter, kilometer, millimeter, nanometer, etc. So, how are we going to relate these different units? Like how many meters equals to 1 kilometer or how many centimeters equals to 1 meter. Now, if we talk about like we are talking about 1 nanometer, then how many meters is 1 nanometer? So, now we need to read about the correlation of different units of a specific quantity, and these correlations are applicable for every unit. Okay, that is, the relation between meter and kilometer is similar to the relation between gram and kilogram. Okay, so now we will study about the correlations of different units. Okay, so SI system has prefixes to indicate multiples or submultiples of a unit. Okay. Now, let's say we have a unit, right? Now, we will go from lower to higher versions of this unit. Unit means we are here considering meter or gram, etc. Okay. So, in this region, we will talk about the submultiples or the quantities that are less than this unit. Okay. So, 10 to the power of minus 24, this is the lowest that we know. This is called yocto or written by small y. 10 to the power minus 21 is called zepto, written by small z. 10 to the power minus 18 is called atto, written by small a. 10 to the power minus 15 is called femto, written by f. 10 to the power minus 12 is called pico, written by small p. 10 to the power minus 9 is nano, written by small n. 10 to the power minus 6 is micro, denoted by mu. 10 to the power minus 3 is milli, written as small m. 10 to the power minus 2 is centi, written as small c. 10 to the power minus 1 is deci, written as small d. Now, on this side, we will talk about the multiples. Okay. that is the units that are higher than this basic unit. So, 10 or 10 to the power 1 is called deca, written as DA. 10 to the power 2 is called hecto, written as H. 10 to the power 3 is kilo, written as K. 10 to the power 6 is mega, written as capital M. 10 to the power 9 is giga, written as capital G. 10 to the power 12 is tera, written as capital T. 10 to the power 15 is called peta, capital P. 10 to the power 18 is called exa, capital E. 10 to the power 21 is zeta, capital Z. 10 to the power 24 is called yalta, capital Y. So, these are the multiples and submultiples of different types of units. Okay. So, we have studied about the SI units, derivation of other quantities on the basis of these SI units, and we have studied about the multiples and submultiples of these basic units. So, in the next lecture, we will study one by one about some important quantities such as mass, temperature, volume, density, etc. And we will study about their conversions from one unit to another. Thank you.